Hi everyone, today I will present an analysis project based on the abalone age prediction dataset. So firstly, the dataset contains 4177 records and 8 features among the categorical variable like the sex, which containing 3 categories like male, female, and juvenile. And then is the numeric variables like the length, diameter, height, whole weight, shocked weight, visceral weight, and the shell weight, and the total weight. Just like the first picture, we can see the all features has no missing values and the data type is floating point, except sex, which is an object type. So for the categorical variable sex, we can use hot encoding to convert it to a numerical feature. And for the numerical features like the diameter, we can use standardization to convert them to a distribution with a mean of 0 and a standard deviation of 1 to eliminate the effort of magnitude. Second is the visualization, analysis, and insight part. First one is the pairwise scatter plot. We can find a strong positive correlation between length, diameter, and whole weight. For example, as length increases, the diameter and weight show a consistent increase too. So this suggests that these variables are predictive of each other and may have a significant impact on the target variable. Second is the distribution and box plots. We found that the distributions of whole weight, shocked weight, and shell weight are slightly skewed to the right, and there are some outliers. For example, the box plots of height and whole weight showed some outliers, which may be outliers in the data or special cases that require further study. Third one is the histograms of categorical variables. For the categorical variable sex, the distribution is relatively balanced with similar proportions of male, females, and juveniles. For rings, like the numbers of rings often used a proxy for age, the frequency distribution shows a decreasing trend with a peak of 9 rings, indicating a larger number of young samples in the dataset. And then is the heat map. Through the heat map, we can see the high correlation between length, diameter, and whole weight. This strong correlation suggests that one of these variables can be chosen as a proxy in modeling to reduce redundant features. Finally, is the bar plot by categorical variables. We found that abalone of different sexes differed significantly in length and whole weight. For example, male abalone generally had higher mean length and weight than females and juveniles. Third part is our model selection and modeling. So in this part, we chose a variety of regression models for comparative analysis, including multilinear regression, lasso regression, ridged regression, elastic net regression, KNN, support vector regression, decision tree, and multilayer perceptron. The performance for each model and its technical details are given below. First one is the multilinear regression model. The MSE is 5.1, MAE is 1.61, our models is 0.53, and the maximum error is around 81%. We can see that the multilinear regression performs well with R-square values indicating that the model explains 53% of the variations, but the maximum error is a little bit high, which suggesting a higher prediction bias in some samples. Second one is the lossal regression. The MSE is 9.38, MAE was 2.28, R squared is 0.14, and the maximum error is around 210%. So the lossal regression performs poorly with lower R square values, and most of the characteristic coefficients are compressed to 0, which indicating an oversimplified model. Third one is the ridged regression. We can see the MSE is around 5.1, MAE is still 1.61, R squared is around 0.53, and the maximum error is 81%. So the ridge regression performs close to multilinear regression, but reduce the risk of overfitting by regularization. Fourth one is the elastic net regression. The MSE is 6.75, MAE is 1.89, and the R square is 0.38, and the maximum error is around 135%. So the elastic net regression performs moderately well, combining L1 and L2 regularization, but not as well as multilinear regression and ridged regression. And the fifth one is the KNN. The MSE is 5.45, MAE is 1.6, and the R square is around 0.5, and the maximum error is around 80%. So KNN performs better than a lower MAE, but the maximum error is still a little bit high. And the sixth one is the support vector regression, which is SVR. And the MSE was 6.44, MAE is 1.77, R square is around 0.41, maximum error is 90% around. So SVR has moderate perform and it's suitable for nonlinear relationships. And that one is the decision trees. We can see the MSE is 8.67, MAE is 2.03, and the R square is around 0.2. The maximum error is 155%. So the decision trees performs actually poorly and may have some overfitting problems. And the last one is the multilayer perceptron, MLP. And the MSE is around 10.9, MAE was 2.48, and R square is totally zero. So actually, MLP performs the worst, possibly due to the insufficient data volume and maybe an optimized hyperparameters. So finally, the result and the analysis. For the best model actually is the multilinear regression and ridged regression with an R square value of 0.53 and an MSE of 5.1 and MAE for 1.61, which is quite high. And the worst model actually is the multilayer perceptron, the MLP, because the R square value is around 0, indicating that the model fails to capture patterns in the data. And also the coefficient of the multilinear regression shows that the whole weight and shell weight have the greatest effect on the target variable. And for the operational decision support, actually we can find that the model's predictions can help fisheries managers to more accurately estimate the age of abalone and thus optimize fishing strategies. And also for the pattern findings, we found that the overall weight and shell weight were key predictors of abalone age, suggesting that these features may be important in biological studies. So in the future, we can further optimize the model, for example, by hyperparameter tuning or trying deep learning models. So it is also an important direction to deploy the model into real business scenarios to verify its effect in real applications. And that is my analysis. Thanks for listening.